Today we'll be looking at latent heat. I will talk about latent heat. The first thing that should come to your mind is change of states. Change of states, that is solid to liquid to gas. That's the first thing that should come to your mind when you hear the word latent heat. To convert solid to liquid, heat is what needed. To convert liquid to gas or to vapor, heat is also what needed. The heat required to convert the solid to what liquid, that is called what the latent heat of what fusion. Then that required to convert the liquid to gas, that's the latent heat of what vaporization. Of course, you can convert gas back to liquid. Then you talk about the latent heat of what condensation. Okay? Now, I will not refer to specific latent heat. We'll talk about specific latent heat of what fusion. The specific latent heat of fusion simply refers to the heat required to change unit mass or 1 kg of what is solid to what liquid. To change 1 kg of solid to what liquid at the same what temperature. While the specific latent heat of vaporization of a liquid simply refers to the heat required to change what a unit mass or 1 kg of what the liquid to what gas at the same what temperature. So that means there is no temperature or change. So for you to be able to do calculations under what latent heat, there is a simple diagram you need to understand how to use. You understand this diagram, you can solve any question under latent heat. So here's the temperature. Here is, okay, let's call this point A, point B, point C, point D, and point E. Let's put here minus theta. Here's 0. And here's what 100 degree was C. Now, point A, the point A there, point A referred to what ice. Ice minus theta degree was C. Then point B is ice at 0 degree C. Point C is water at 0 degree C, because the ice will melt to get water. Then point D, point D is water at 100 degrees C. Then point E referred to as steam at 100 degrees C. Now, if you ask to convert ice at a negative temperature to ice at 0 degrees C, A to B, the formula I'm going to use, because here we have an increase in what temperature. There's a change in what temperature. So I'll get NC change in what theta. That's the formula I'm going to use at that point. M representing what the mass of the ice. Then C representing what? The specific heat capacity of what ice. And then we have the change in temperature, which should be 0 minus whatever temperature is given as what the negative what temperature. Then for point B to C, if you have to convert ice at 0 to water at the same temperature, which is water at 0, the formula at that point is what? mL, which is what the mass of the ice. Then the latent heat of what fusion of what ice, that's the specific latent heat of fusion of what ice, that's what your L. So that's the formula which at this point mL. Then for C to D, you want to convert water at 0 degrees C to water at 100 degrees C. There's an increase in temperature. So what we have is MC change in theta. M will now represent the mass of the ice. Then C represents what? the specific heat capacity of ice. Then we want to convert water at 100 degrees to spin at the same temperature, which is what 100 degrees C. The formula again becomes what M what L. M representing what? The mass of water. L representing what? The specific latent heat of what? Vaporization of what? Water. If you understand this down, you'll be able to solve any question under latent what heat. As we are going to see what shortly, I will give a step-by-step approach how to solve questions using this diagram right from a negative temperature up to still at 100 degrees C. But first, there are some parameters I'm going to give to you, which is always given if you are doing calculations under latent heat. And even if you are doing calculation under quantity of what heat, they always give you those parameters. But it is needed for you to solve what questions under latent heat and specific heat capacity. So let's look at the first one. So for the questions I'm going to be giving to you, where necessary, that if it's not stated, if I don't state it, or if you don't see it on exam during your exam, okay, but it will always be given. It will always be given. Just make use of these following parameters. That's what I'm going to use in solving questions today. So the first one is the specific latent heat of ice. Specific latent heat. Specific latent heat of ice. That's specific latent heat of fusion of ice now. Specific latent heat of fusion of ice. So I'm going to use it as 335 joules per gram. But there's no change in temperature. Then specific latent heat of vaporization. Specific latent heat of vaporization of water. Specific latent heat of vaporization of water. That is 2250 joules per gram. Then specific heat capacity. Specific heat capacity of water. I'm going to use 4.19 joules per gram per Kelvin. Then specific heat capacity of ice will make use of 2.14 joule per gram. 2.14 joule per gram per Kelvin. Okay? Let's take note of these parameters here. That's what we are going to use solving questions today. Okay, let's take a look at the first example. Let's see how we can calculate questions under latent heat using that simple diagram I just showed you. Okay, sometimes I'm giving this unit in joules per kilogram per Kelvin, so it depends on what you have. So you may need to do some conversion from gram to what kilogram. So depending on the question you have. So like I said, these parameters will always be given. So the given parameters will enable you to know if there's a need for you to convert from gram to kilogram or kilogram to gram. So it depends on what you have in your question. That's what will determine the conversion you are going to use. For now, I'm going to be using this one. So most of the questions I'm going to give to you. Most of the questions I'll give to you. Then it will be no need for us to convert because I'll be using what grams in most of the question. Let's say example one. Let's say example one. Say calculate the heat required. Calculate the heat required to convert 12 grams of ice minus 5 degrees C minus 5 degrees C to water at 0 degrees C. All right, let's start with a very simple question. Let's see this one. Calculate the heat required to convert 12 grams of ice at minus 5 degrees C to water at what 0 degrees C. Remember, I said all you need to do is just to draw the diagram. Let's draw a diagram. So it's like that. Now, we're going to convert ice at minus 5 to water at what 0. Now, this point here is where we have the ice at what minus 5. Okay, and just increase the diagram size. Okay, so now if I put the figures here, say ice at what minus 5, so I'm at minus 5. So water at what 0. So water at what 0. Water at 0 is at this point here. So AB was C. Here, here is 0. Remember here, at this point. Here is ice at 0. Here is water at what 0. So now since you have to convert 12 grams of ice at minus 5 to water at what 0 degrees C, the diagram simply tells you the number of calculations we are going to do. So from here, I'm going to do what 2 calculations because I'm moving from here up to this point like this. So here and here. So I'm going to make use of 2 calculations. And at this point here, there's no temperature change. So I'll have what NN. Why from here I'll make use of MC changing what theta, because there's a change in what temperature. So the total H required is what? I'll make use of MC change in theta plus what M what L. If I do that, I will be able to get the required answer. So let's substitute now. If we substitute now, we have heat now. Heat required, that's the total heat required now. It will be MC change in theta plus what M what L. Now, since we're talking about what ice here, from here to here, ice increase from minus 5 to 0. So what I'm going to make use of what is the specific capacity of what the ice. So I'll get the mass of ice given is what 12 grams. So I have 12 times the specific capacity of ice. That is what 2.14. Then the change in temperature, that will be 0 minus what 5. And 0 minus 5, that will give us what 5. And 0 minus what 5. Minus is what plus. So I left it for 5. So times what 5. We have this one. Then plus the mass of ice 12 times at this point the ice is converted from 0 to water at what 0. So we're talking about what? The latent heat of what fusion. The latent heat of what fusion. The latent heat of what fusion of what ice, which is what 3315. That will be 3315. The latent heat of fusion of ice. If it was here from here up, at 100 we talk about what vaporization. Water is vaporizing. That's what we talk about. Specific latent heat of what vaporization of what water. Let me just use V so that you understand this one for vaporization. This one is for what fusion, that is what F. Okay, so you'll talk about what fusion because it's what melting. You'll talk about what vaporization. So this is the formula I'm going to use. And when you multiply that now, you should get your answer. So we have 12 times 2. Okay, 12 times 2.14 times 5. Value was 1284. And we have 12 times 335. Target was 4020. When you add up that, 1280. That was 5,304 joules. That is the heat was required. That is the heat required to convert 12 grams of ice at -5 degrees to water at 0 degrees C. So you see how this particular diagram enables us to know the number of times we are going to do what the calculation. So from the diagram, I'm going to have two calculations here. The first one and the second one to get what the heat will require. It's just as simple as that. Let's take another example. Let's say calculate the heat required to convert calculate heat required to convert 20 grams of ice at 0 degrees C to water at the same temperature. Calculate the heat required to convert 20 grams of ice at 0 degrees C to water at the same temperature. Now, if you have a question like that, we still make it on the same diagram now. That's the diagram we're going to use throughout. But this time, we are going to have okay. So now, ice at what 0, which is here, the ice is here, this point B, A, B, C, D, E. So the ice is at point B, okay? 20 grams of ice at 0, this ice at 0. So water at the same temperature, this water at the same temperature. So the heat required in this case, from the diagram for what I have, I'm moving from here to this point. So what I'm going to have is what M1 L. So that will be what? The mass of ice, which is 20, times the specific latent heat of what fusion of what specific latent of fusion of what ice, that's your 3315. We multiply this one, we multiply that. I'll get 6,700. 6,700 joules of heat. That's the heat required to convert 20 grams of ice at 0 degrees C to water at the same temperature. To water at the same temperature. So all you need to do is just draw the diagram, input the given parameters, know the number of times you are going to do that calculation. And once you do that, you get your answer. Let's take a look at example 3. Example 3. Let's say calculate the heat required to convert ice at 0 degrees C. To convert ice at 0 degrees C, you convert it, let's say 15 grams. To convert 15 grams of ice, to convert 15 grams of ice at 0 degrees C, to water at 10 degrees C. To water at 10 degrees C. Now, calculate the heat required to convert 15 grams of ice at 0 degrees C to water at 10 degrees C. So the same thing, look at the diagram again. I'm trying to put those parameters for me to know the number of times I'm going to do my calculation. So I have this, okay. So now here's 0, here's minus theta, here's 0, and then here's 100. So now the mass of ice is 15. Okay, now we are converting the ice out towards 0. Okay, this is where ice at 0 is. Ice at what 0, that's point what B. Ice at 0, that's point B. So water at what 10. Remember, here is what water at what 0. Okay? And at that point what 0, you continue to heat the water, the temperature is going to what rise until it gets to what 100. So I can pick any point here. Let's say this point here. Let me call that point 10. So now what I need to do is I'm moving from here to this point. That's the first calculation I'll do. Then I'll move from here, point C, to this point. That's the next calculation I'm going to do. So that means I'm going to have what two formulas. From here to here, B to C, there is no change in what temperature. So I'm going to have what M what L. So heat is what ML. Then plus what required to convert from here to here, there's an increase in temperature. So I'll get MC change in what theta. MC change in what theta. Now the mass is given as what 15 watt grams. Then here to here we're talking about what? The specific latent heat of what? Fusion of what ice for the ice is what melting. Specific latent of fusion of ice is 335 plus the mass of ice again, that's 15. Then here, the ice has been converted to water. There's the water that is what, the temperature of the water that is what increases. So I'm going to make use of what specific heat capacity of what? Is it ice or water? It's going to be what? Water. The reason is because the ice has what melted. From here up, would have made for specific capacity of what? Ice. Now that it has been converted to water, so from here up, we make use of the specific capacity of water, which is given as what 4.19. Then the change in what temperature? The initial temperature is 0, the final temperature is 10. So 10 minus what 0? That will give us what 10. So the change in temperature is what 10. So now we have the first calculation and the second calculation. We do that now. We get the heat required to convert 15 grams of ice at 0 degrees C to water at 10 degrees C. We have 15 times 335. We have 50, 25 here. We have 15 times 4.19. We have 6285. When you add up, now it was 565, 5653, 5653, 56535, 56535. That's 5025 plus 685. 5025 plus 628. Okay, that will be 11,310. 11,310. Okay, that's 11,310 joules. That's what the heat was required to convert ice at 0 degrees C to water at what 10 degrees C. So if you understand this diagram, you will be able to do any calculation under what latent heat, whether I'm moving from down up or I'm moving from upward down. Let's see one question to illustrate when you convert ice, when you convert, okay, let's say water now, when you convert water to what ice. Let's take it an example. Calculate the heat required. Try to do some very short questions today, because I'm going to find some lengthy questions, especially if you're doing an exam that comprises of both theory and objective. Calculate heat required to convert, let's say 25 grams of water. To convert 25 grams of water at 12 degrees C to ice, at 0 degrees C. By this time, the water is running at 12 degrees C, so let's use this point here. Let's call this point 12. 12 degrees C. The mass is what? 25 grams. 25 grams. So ice at what? 0. So this time I'm moving from up here. First, we'll convert from 12 degrees C to what 0 degrees C does. So convert the water first from 12 degrees C to what 0 degrees C. Thereafter, we'll convert the water from 0 degrees C to ice at what 0. Now moving from up here to this particular point, that is from, okay, let's call this point point F now. So I'm moving from F to D. I'm moving from F toward D. So again, to move from F to C, okay, to move from F to C, there's going to be what? A change in what temperature? There's going to be a change in temperature. So I'll get what? MC change in what theta? There's going to be a change in temperature. We are converting what the water at 12 degrees C to ice at what 0. And after that, we convert the water from 0 degrees C to ice at the same what temperature. There's no change in temperature here. So I'm going to have what? M what? Air. The mass of ice is 25. Here we are going to have a specific heat capacity of water. It is given as what? 4.19. Then the change in temperature will be 12 minus what? 0. Change in temperature is what? 12. Then plus mass of water, say 25. Then from here to here, I'm going to have a specific what? Latent heat of what? Fusion. Specific latent heat of fusion of ice, which is what? 3,315. 3,315. Multiply that one. 25 times 4.19 times 12. 7. Well, add up 8375. So 1257. So then 9,632. 9,632 joules. That is the heat what required to convert 25 grams of water at 12 degrees C to ice at 0 degrees C. Okay, if you are enjoying this lecture, ensure you hit the subscribe button, which is the bell button you are seeing below this video. Okay, if you are watching on YouTube. Now let's take a look at one more example on this one. Let's say something that has to do with what? Vaporization. Let's take example 5. Let's take example 5. In the part 2 of this series, what I'll do is I'll do some more lengthy questions and some more technical questions, which you are going to find under latent heat. No matter how the question is, the formula is still the same thing. Understand this diagram or draw this diagram. Once you can draw the diagram and put in the needed parameters, you can solve any question under latent heat. So let's see. Calculate heat required to convert 18 grams of water, 18 grams of water at 25 degrees C. To steam. Now, if you have a question like this, the first thing I said you should do is what? Draw the diagram. We draw the diagram. Now, when you draw this diagram, here is 0. Point B, C, there's point A, C, D, and point E. Now, this time around, the mass of the ice, okay, mass of water now. The mass of water is given as what? 18. The mass of water is given as what? 18. Because the calculating should require to convert 18 grams of water at 25 degrees C towards steam. So the initial temperature of water is 25. I'll go back to the diagram. Now, let's put 25 somewhere around here. Here's 25. Okay. So steam. Now this point you have water at 100 degrees C. And here you have steam at 100 degrees C. So the first is to move from here to these points. Then we'll move from here to these points. So let's call here point M. So we'll move first from M to D, then from D to E. So I have two calculations. The first one is for the increase in temperature. Another one is for what? The vaporization at a constant temperature. So now I will have heat equal to, from here to here, I'll get MC change in theta, but there's a change in temperature. Then from here to that point, from D to E, I'll have what? ML. The mass of ice is 18. And at this point, we make use of what? The specific heat capacity of water. The specific heat capacity of water, that's 4.19. The change in temperature from here to here, this is what? 100. This is 100. So I get 100. The change in temperature is going to be 100 minus 25. And that'll give us 75. Plus mass of water is 18. Then we have what the latent, the specific latent heat of what? Vaporization of water, which is what? 2250. 2250. So I have the first calculation on the second one. So now we multiply that. So we'll multiply that now. We get 18 times 4.19 times 75. We have 565. Five 6.5 plus 15 times 2250. You have 40,500. When you add up 5656.5, you get 46 156.5 joules. That is the heat what required to convert 18 grams of water at 25 degrees C to one steam. Now, this topic is not a difficult one. Try and go through everything we've done again. Play the video again so that you get an understanding of everything we just did on this topic, latent heat. So that by next class, we'll start talking about some more lengthy questions of this. How to do a conversion from the negative temperature towards steam. It will not be something that is difficult for you to understand. Until then, have a lovely day ahead. I'll see you in our next class.